All right, welcome back. Hope you have had a nice break. Are there any questions before we go to session 3? Okay, before break, we did session 1 dealing with multiple seasonality. And in session 2, we dealing with the variables affect each other. Now we are going to do the neural network. It is based on the simple mathematical models of the human brain, allow for complex non-linear relationships. The architecture behind the neural network is that we could have multiple input, okay, and we produce output. You can interpret this input 1 to input 4 as X, produce output Y. If this is the case, I'll try to make this bigger. Yes, I can do it bigger here. If this is the case, we call this is the simple neural network. It is like the linear regression, okay? But if you have this picture here, you have multiple input, you don't have immediate output. Instead, you have some hidden layer. We call this each dot, each circle. It is a neuron, okay? And in this case, the input 1 also goes to the 3 hidden neurons here. And finally, we produce the output. This we have 1 hidden layer, okay? And this one is more complex than the first one. So our focus will be based on this one, because the first one, we can simply use the linear regression to do it. Okay. The final exam will have some questions on this part, okay? So for example, I give you NNA, by the way, this NNAR, so NN represent neural network, AR, autoregression, so neural network autoregression. If it is used 2 parameters, the first one indicate lag, number of lag, and the second one is nodes in the hidden layer. So for example, this diagram, K equal to 3, you have 3 nodes in this hidden layer. And this one, this 12 should be subscript. Means you need, lag is 3, so you use yt minus 1, yt minus 2, yt minus 3. But most often, we also use the last data in the season. So in this case, it is monthly data will also include yt minus 12. Okay, so the correct answer should be put all of this as an input. And this number 2 represent 2 nodes in the hidden layer. 2 nodes in the hidden layer. And this 12 indicates it is a monthly data. Monthly data. So the general format, we use the NNETR, this is the function. This function fits this model. So they're different, okay? We use this function to fit this model. In this model, this capital P, usually it is 1 by default. And P represents the number of seasonal lags. Seasonal lags. All right, so pay attention to this part. There are questions on the final exam. Okay. So next, we'll take an example using the sunspots. Okay. What is the sunspot? It is just the magnetic regions that appear as dark spots in the sun. Why we are interested in sunspots? Because the telecommunications are interested in this because the sunspot will affect the radio wave. So telecommunication companies, maybe Elon Musk, SpaceX, they will be interested in the sunspots, okay, because they want to forecast the future difficulty periods for these sunspots. So we have data available. The data name is the sunspot area. So let's look at what this data looks like. Okay, so go to R code sunspot area, view. So type in view. Sunspot area. It's just the numbers. It's just the numbers, okay? It has many years data. Those are over the years. Try to locate my document. Maybe put it here. Okay. So that is the data. Next, we are going to use NNETR, use this function. Apply this function to this data, put the result in fit. Lambda equal to 1 to ensure there is a stable forecasting. After we produce this variable fit, we are going to do the forecast for future 30 years ahead, 30 years ahead. And the forecast format is a graph. Okay. So let's do this. Create a model, then use this model to forecast. See, this is the model. Okay, the black represents the existing data, original data. The blue line here, the blue line is the forecast. Okay, is the forecast. This is a graphical representation about the forecast. If you want the number format of this forecast, you can just put the bracket here. Okay. So you can just put the forecast. For example, if you want just forecast 10 years, h equal to 10, okay? So just copy this to get the numerical value of the forecast for 10 years ahead. You could put 30 years, but I just use the short form, okay? You get the forecast. As you can see, we just use this model just produce point forecast. That's why here we all have the solid line. Okay. So this is the sunspot produced a model, neural network autoregression model. Use this model to forecast 30 years ahead. 30 years ahead. Because the forecast result is just a point forecast. So how do we produce the prediction intervals? Okay, this is this session about. Because neural networks is not based on stochastic model, prediction intervals is not automatically available. That's why we need to use the sample path and then using the bootstrapped to get the intervals, prediction intervals. Okay, so how do we produce 9 possible future sample paths? We use the R code. So this means we want to produce 9 sample paths. Okay, each time we do the simulation. Okay, but before that, we need to, it is use a matrix. Okay, use this data sunspot area. But before that, we produce a matrix because we want 9 sample paths. Okay, so the matrix result is a time series. The result we put into SIM. Okay. And then we do the loop. We do this for loop 9 times. Each time, do I have a fit? We do have this fit, FIT fit here. Remember, we do use the model. See, we have fit. This one connected to this example. We do produce the fit first, because after we produce the fit, we do the forecast. We only produce the point forecast. Now we want to produce prediction interval. That's how come this code. Okay, it's connected to the model we did before, just a few minutes before. Okay, and then we want to use the graphical format, auto plot. Okay, and this code will probably take 1 or 2 minutes. So I will just copy. It's not bad. This time it's very fast. Okay, as you can see, this series 1, series 2 until series 9. We remember we produced 9 series, and those are the original data, and those are based on the intervals. Okay, prediction intervals. So that is this part. I do. And now you want to do the forecast 30 years ahead. We already did that. No, okay. Forecast feed. We already did that. Yeah, this one. Okay, so in the code we have maybe, let me PR. Did we do this? Okay, let me run this code to see what's happened. So it takes, maybe I will come back to the code. The PI in this code, PI, it is a logical flag indicating whether to plot the prediction intervals. Okay. So if we type in this code, it will give us prediction intervals. And because I put the brackets, so the result should be the numeric format, number format. Okay, this code comes out. You see this one, this code. I just ran, it comes out as this result, okay? So next, I will produce number format of the forecast. So just copy this code. By the way, this is not in the textbook. The textbook only gives you the graphical representation of the forecast, okay? So I do both graphical and numeric representation of the forecast. So I will forecast 30 years ahead. So again, it will take some time, okay? So this is the result of the point format, as well as the interval, 80% confidence interval, 95% confidence interval. So this may take a few minutes if I want to. Okay, any questions? Okay, while we waiting for the result would be like this. I already did this, will be like this if you put point estimate, okay. Any questions? Yeah, it comes out now. So this is the result, say, okay, you have a point estimate, you have 90% confidence interval estimate, 95% confidence interval estimate for 30 years from 2016 to 2045. Any questions? All right, so that is the neural network autoregressive model. We use one example, sunspot area. And in this example first, we did a point estimate. Then we did both point estimate and prediction interval. Okay. So that concludes session 3, okay. Neural network. Session 4, bootstrapping and bagging. So you need to know, again, final exam have this question: what is the box Cox transformation? There's a typo here, the box Cox transformation. This is extra. It is just to transform original data. So for example, take square of original data, or take square root, or original data raised to power 1/3, take logarithm for original data, 1 / square root of original data, 1 / original data. All of these are box Cox transformation. Okay. So now what is bootstrapping? It is just generate new time series data that are similar to our observed data. Okay. Use simulation to produce some samples similar to our data. So now this, I will introduce a new data. It is about debit card, monthly expenditure on debit card in Iceland. This data is from January 2000 to August 2013. Okay, we are going to use 10 bootstrapped versions. So first of all, let's view this data. The data name is debit cards. This is the data name. So let's take a look at of this data. View. So this is, it is just the numbers, all the numbers, okay. So this is this data. So next, what we are going to do, we are going to put this original data, use original data, produce 10 bootstrapped versions. Bootstrap model use this one, not just bootstrap. It also has a bld.mbb. Okay, so this is the whole thing here is bootstrap. Okay. And this as input, this is the pipe. Use this one as that data frame, and the result put into the time series data. The data from 2000, it is monthly data. Okay. And then take auto plot of original data plus the bootstrapped, the boot series. So this is the boot series. Okay. So put all of this into the boot series, then produce graph. Okay, so this is this code. And so let's copy the whole thing here, from here to here. So you see, there are actually 10 bootstrapped versions here using different colors, as well as original data. Yeah. So this is this code. So next, we are going to produce prediction intervals from bootstrapped series. There are three steps. First, we need to simulate many time series, okay, to do the simulation. So use this code to do simulation. Because we just do the simulation to produce many similar data. This is first step. Second step, for each of these series, we fit ETS model and simulate one sample path from that model. This is the second step. Okay. This code took me half hour to run just these 4 lines here. So I'm not going to do it here. I waited for 30 minutes. So after you run this code, it will give you this output here. Okay, give you output here. This is step 2. And finally, you calculate the mean and quartile of the simulated sample path, mean, lower bound, upper bound, and then you can get the result, the prediction interval here. Okay. So if you are interested, you're waiting for 30 minutes after you get this code run. Okay. And then you do these steps, you will come up with this result. Okay. All right. So in this, let's conclude our last session. So if you go back to the very first page, that is the we covered a lot, but What is my? So here, we covered 4 sessions. In complex seasonalities, we're dealing with the data, the call center data, not only have daily seasonality, but also have week seasonality. And in session 2, we did example about consumption income. Those 2 variables affect each other. Consumption affect income, income affect consumption. Okay. And in neural network models, we did the sunspots. Okay. And also produce the prediction intervals. Last section, we did the credit card, okay, using the bootstrapping. Okay. And that's all for this session. Any questions?
Professor, I have a question here.
Oh, sure.
So in this chapter, we use like different codes to, like do the forecasting. For example, we use like a code to do the sunspot area. So in the final exam, we will ask something like, like what's the code to get this formula and how to calculate that? Do we need to memorize, like those coding you show us, like today?
Thank you, Jie. The code, if I explained, I may ask, remember it is open book, open notes. Any questions, if involved in this chapter, it is in this document, this Word document. For example, I explained this one, right? For example, by 2. You should know the output for week 1, the label in x-axis, see? Week 1, week 3, week 5, week 7. That is by 2. I explained. So everything I explained, maybe it will be on the final exam. I didn't explain something. For example, I didn't explain the actual grade here, maybe not. It is not on the final exam. So pay attention, my explanation. I will not ask you the complete code, no, but I will ask you part of the code. For example, end 4, what does it mean? It means the first 4 weeks. Okay, and for example, so just for example, I want to produce numerical representation. You put the bracket, okay? You start with the bracket, end with the bracket, you get the numerical representation, okay? So the final exam questions are taken from this Word document, okay? I just copied and pasted, just change a little bit the numbers. Sometimes I even don't change the number. Just for example, this one, obviously you want to forecast for 2 days ahead based on the 5 days. I explained this. So if I give you this code, give you multiple choice question, I say this code forecasts 3 days ahead, 2 days ahead, 4 days ahead. The correct answer 2 days ahead. Right? So not complicated calculation. Most questions are multiple choice questions. Remember how many more questions? Yeah. But some short answer questions demand calculation, but not complicated calculations. So everything I did in class could be on exam. Okay. Thank you for your question. Any other questions? Any other questions? Okay, this is our last lecture. I want to take this opportunity to thank each and every one of you coming to the class. Usually I do not take attendance, but today I do take the attendance just for my own reference purpose. Because people who are coming to class will always come in class. So if you are here today, I will assume you were here yesterday, you were here, last week, the week before. Thank you again for your participation. I would also want to express my gratefulness for students who are asking questions, answering other students' questions, and also contribute your discussion on the discussion board. Although there is no mark for discussion, but some students did contribute your participation. Thank you again. I know it is not easy time for everyone. You are taking courses, you have family responsibilities, part-time job. I appreciate your effort and contribution to this course, okay? For the final exam, just try your best effort. Do not stress out. Focus on I give you the final exam information, okay? Focus on those chapters. Pay attention to the class, the live class. We go over some concept. If you have any questions, please email me, and please allow 2 business days to have your email answered. And during the final exam, I usually do not suggest you ask questions during the exam, but unless it is emergency, okay, you can write your questions. So I welcome your questions after the exam, not during the exam. That's all for today. Any last minute questions? I'm going to stop recording so that